The altitude of a triangle is increasing at a rate of 1.5 centimeter per minute, while the area is increasing at this rate. So we got a triangle, and it talks about altitude changing, area changing, and we need to find the rate of change of base. So we don't have to draw a diagram, but let me just draw a generic triangle. Okay, I mean it's a different color, means you don't have to do that. So we have a triangle, then so that's 90 degrees, so altitude or height, and it talks about base as well, and it also says about somewhere area. And area, there is a formula, A is area. We know the formula of the area of a triangle. Area is half. So area is in fact half times base times height. Okay. I mean, in this question, in fact, when we read, there are three variables because the altitude h is changing at the rate of 1.5 centimeter per minute. So rate of change means derivative with respect to time. So d over dt, rate of change of h, altitude or height, is given 1.5. We don't have to worry about units now. While the area is changing, okay, here altitude or height was changing and area is also changing, means d over dt, that's the rate of change of area, is at the rate of 5. Okay. Now it asks at what rate is the base of the triangle changing, the base. So d over dt, rate of change of base is what? At the moment, or when, at that moment, the altitude is 9. So that height is 9 and the area is 81 square centimeter. Okay. So in this question, read the question carefully to get this information. So the altitude was changing, so area was also changing in this rate. Rate means d over dt derivative, and question asks what is the rate of change of base b at the moment, because these things are height is changing, altitude changing, area changing, but at the moment when exactly height or altitude is 9 and area is 81, what is the rate of change of base, dB over dt? So there are three variables. Variables means when they are changing, something is changing, area, height changing, area changing, base changing. Now the relationship among these three variables is given by this formula. Okay, oftentimes the relationship will be just the formula. We know area equals 1/2 times base times height. Now to find these rates, we differentiate both sides with respect to time. So differentiate both sides obviously with respect to time t. So if we do that, so I'm going to write d over dt of a, which is same as dA over dt by the way, equals derivative of right hand side, which is a product, but 1/2 is constant, so we can just go past this one, and derivative of this product. So I'm just setting up this left hand side is just d over dt in short, 1/2. Now derivative of a product, okay, in this case b is changing, h is changing, both are variables and they are in product, so we must use the product rule. So what is the product rule by the way? When we have u and v, and when we are finding derivative, that is derivative of first factor times leave second alone plus leave first alone, find the derivative of second. Okay, so we are using that here as well. So 1/2 times everything, so derivative of b, dv over dt times h plus leave b alone dH over dt. Okay, that is from this this product rule. Now we found the rates, so let's plug in the given values here. So dA over dt, if we look at closely here, dA over dt is 5. Okay, so this is 5 equals 1/2 dB over dt. Okay, that is, it says what? That's what we are trying to determine. So dB over dt, just leave as it is, times h. H is 9. Okay, it's given, plus b. Okay, b is missing. In fact, we should have only one thing missing. So dB over dt should be the only thing missing, but b is also missing, so we need to determine b. So I'm going to come back to that in a moment. Times dH over dt is given here 1.5, or which is 3/2. 1.5 is same as in fraction 3 over 2. So this b is missing here. So to determine this b, we need to use this relationship that we wrote at the beginning, the relationship among the variables. So we need to use this one more time. Okay, a equals 1/2 base times height. Okay, let's do that on side. So we don't need this one. Let me erase this. Okay, a equals 1/2 times base times height. And if we read this question, when a is 81, half times b, that's what we are trying to determine. H is 9, altitude or height 9. Okay, 1/2 means multiply both sides by 2 and divide by 9. So 81 multiply by 2 divide by 9, and this way we can isolate b. 9 goes 9 times 9 times 2, 18. So b is 18. So this b is 18. So let's come back and write this as 18. 18 times 3/2. We can simplify this, and 1/2 outside we can multiply both sides by 2, or we can distribute 1/2 inside. It's up to you. So basically now this is an algebra problem where we are trying to determine this, or isolate dB over dt. 1/2 multiply both sides by 2, that way 1/2 is gone. This is 10 equals, this is 9, I'm going to write number first, 9 dB over dt plus, okay, 2 goes 18, 9 times 3, 27. Okay, 18 times 3/2, 27. Now subtract 27 from both sides, then divide by 9 to isolate this. 10 minus 27 is negative 17 equals 9 dB over dt. Now divide by 9, that gives dB over dt equals negative 17 over 9. Okay, 17 over 9. And this is, b means base, length, so just centimeter per second. There was area, that was a square centimeter per minute, but in this case centimeter per minute. Okay, not second. The question says, in fact the base is decreasing. This negative sign means decreasing. So here the altitude was 1.5, so we didn't write positive. Increasing, but this is decreasing. You may leave here, or you can say that is, in fact, the base is decreasing at the rate of 17 over 9. When we say decreasing, we don't write negative. 17 over 9 centimeter per minute. Final.